Okay, let's look at a few more examples of differentiating using the chain rule. So we're asked to differentiate the square root of x cubed plus 6x with respect to x. So let's write down first of all the rules of differentiation that we know. So we have the f of x column and the f dash of x. So when I differentiate x to the power of n, so at this stage you should know these fairly well, nx to the power of n minus 1, ax to the power of n, I get n times ax to the power of n minus 1, and differentiate a constant, I get 0. So the square root of x cubed plus 6x doesn't look like any of them. So we're going to have to use the chain rule to differentiate. So I'm going to start off by writing this as, I'm going to do it both ways actually. I'm going to use the dy over dx notation, and I'm going to use the function notation. So I'll do the function notation first of all, and I'm going to start off by writing f of x is equal to the thing that we want differentiated. So the square root of x cubed plus 6x, square root of x cubed plus 6x. So, okay, if you remember when we differentiated square roots before, we didn't leave the square root. We wrote it as to the power of a half to make it look a little bit like this. So that's what I'm going to do first. I'm going to rewrite that. F of x is all of that, x cubed plus 6x all to the power of a half. It means the same thing. We haven't differentiated it, remember? We've just written it in a different way to make it easier to differentiate. And now, okay, we've got a function inside a function. The first function is the x cubed plus 6x bit, and the second function is all of that to the power of a half. So let's write down the two functions and give them names. So we'll say h of x is equal to the x cubed plus 6x bit plus 6x, which is easy to differentiate. And then let's call it g of x is all of that to the power of a half. So it's going to be h of x to the power of a half. Both of these are easy to differentiate now. So here I can find h dash x, which would be 3x squared, just using the x to the power of n rule, plus, and differentiate 6x. It's a sum, so I just do each bit individually. I'll get 6. I can differentiate g dash x, and I will get, we've just got something to the power of a half, h of x to the power of a half, something to the power of a half. So I can use this rule here. So it's just going to be a half times h of x to the power of, it's going to be a half minus 1, and a half minus 1 is minus a half. 1 over 2 minus 1, which is minus a half. So now, okay, I can fill in here. I've got a half. Instead of writing h of x, I'll write what h of x actually is. It's x cubed plus 6x. So x cubed plus 6x, and it's all to the power of minus a half. So to the power of minus 1 over 2. So now to find f dash of x, if you remember from the previous video, I just multiply h dash x and g dash x. So h dash x times g dash x. So we got up here, we have a function inside a function. The first function is x cubed plus 6x. We differentiate that. The second function is all of that to the power of a half. I differentiate that, and then I multiply those two things together to get this differentiated. So that's going to be equal to 3x squared plus 6. So 3x squared plus 6 multiplied by g dash of x, which is a half x cubed plus 6x, x cubed plus 6x, all to the power of minus a half. So minus 1 over 2. And that's it. We've differentiated this function up here. Okay, I'm going to do that again, but I'm going to do it using the dy dx method. So I'm going to start off this time by writing, so it's the same question, differentiate this, but I'm going to start off by writing y is equal to the square root of all of that, x cubed plus 6x. And what am I going to do? Okay, first thing I'm going to do is, rather than have the square root, I'm going to write all of that to the power of a half. So I'll get y is equal to all of that, x cubed plus 6x, all to the power of a half. Anytime you differentiate a square root, start off by writing it to the power of a half. And now I've got a function inside a function, so I'm going to let h be this part. So h, same as I've done over here, except I've h of x here. I'm just going to write h here, is x cubed plus 6x. Here, then, if h is that means that y is equal to, well, y is equal to all of that to the power of a half. So y is equal to h to the power of a half. I've got a h and an x, so here I can find dh over dx, which will give me 3x squared plus 6. Here I've got a y and a h, so I find dy over dh, which will give me a half h to the power of minus a half, same as I have here. And then dy over dx is just dh over dx multiplied by dy over dh, so times dy over dh. And then, so I just fill that in. So dh over dx, 3x squared plus 6, so 3x squared plus 6, multiplied by dy over dh, multiplied by a half h to the power of minus a half. And that's it. I can fill in what h is, because h is this here. I should have done that up a little bit above. So I guess it doesn't matter where you do it really, but 3x squared plus 6, but you should do it at the end, times a half, and instead of writing h, I'm going to write x squared plus x cubed plus 6x, because that's what h is, x cubed plus 6x to the power of minus 1 over 2. So it doesn't matter which method you use, you can use either method. Okay, let's have a look at one other question. So we're going to, I have it written out here, we're going to, question says, find the slope of the tangent. It's just written in a different way. It's almost the same question, it's very similar. But find the slope of the tangent to the curve. So we got a curve, here it is, y is equal to this. And we got to find the slope of the tangent to this. So really it's asking the slope of the tangent and the slope of the curve are the same thing. So it's asking us to find the slope of the curve. So to find dy over dx at the point minus 1, 2. So I'm going to find dy over dx. So we have y is equal to the square root of x squared plus 1. I'm going to rewrite that as y is equal to all of that, x squared plus 1 to the power of a half. See if you can do this if you want to stop the video and see if you can get the same answer as me. So if you want to stop the video, try and do it yourself and then come back and see how I do it. So we have y is equal to all that to the power of a half. I'm going to say, okay, we've got two parts. We've got a function inside a function. The first bit is the x squared plus 1 bit. So I'll say h is equal to x squared plus 1. That means that y is equal to all of that to the power of a half. So y is h to the power of a half. Here I can find dh dx, so dh over dx is equal to 2x, just using the normal x to the power of n rule. Here dy over dh is a half h to the power of minus a half. A half minus 1 is minus a half. I can fill in what h is, so that's a half. H is x squared plus 1, x squared plus 1 to the power of minus a half. And then dy over dx, move it up, dy over dx is just dh over dx times dy over dh. So it's just this multiplied by this. So it's 2x times a half x squared plus 1 to the power of minus 1 over 2. The question asks us to find the slope of the tangent to the curve, which is this. This is the slope of the curve, but it's the same as the slope of the tangent to the curve. So find the slope of the tangent to the curve at the point minus 1, 2. So that means, another way to say that would be find the slope of the tangent to the curve when x is equal to minus 1, because at this point minus 1, the square root of 2, the x part is minus 1 and the y part is root 2. So when x is minus 1, so we can just fill in minus 1 into this for x. So dy over dx, the slope would be twice minus 1 times 1 over 2, a half multiplied by minus 1 squared plus 1 to the power of minus a half. I'm going to let you work that out yourself. If you just, you don't need to use a calculator, but if you want to just multiply it out, 2 by minus 1 is minus 2. Add up the brackets first, so minus 1 squared, don't forget, is 1. And then you get 1 plus 1, a half of 1 is 1. 1 to the power of minus a half. So you should be able to work that out yourself.